given problem statement is f of x comma y is equal to 2 minus x minus y, and the given limits are 0 less than or equal to x less than or equal to 1, and the y limit varies from 0 to 1. So we are going to find the marginal density function for x as well as y, and in the second subdivision we are going to find the conditional probability of x given y as well as the y given x. So first we are going to find the marginal density function. So the first one is marginal density function of x. So the formula is f of x is equal to integral of f of x comma y into dy. So this is the formula for the marginal density function of x. So first we are going to substitute the value f of xy. We are going to substitute 2 minus x minus y. So this is the value we are going to substitute, and next we are going to integrate these values. So while integration it becomes integral of 0 to 1 2 dy minus of integral of x dy minus of integral of y dy, and the limits also we are going to substitute. So first I am going to differentiate the first term. So I am going to write it 2 as it is. We are going to integrate dy alone. While integrating dy I get an answer as y, and the next one we are going to write the x as it is, and we are going to integrate dy alone. While integrating dy I get an answer as y. And the next step we are going to integrate y dy. While integrating y I get an answer as y square by 2. Next we are going to substitute the limit. In the first I am going to substitute the upper limit. Here the upper limit is 1. So we are going to substitute that upper limit only for the values of y. So we are differentiating with respect to y. So we are going to substitute y itself. So while substituting y we get an answer as that is the 2 into 1 minus of the lower limit, that is 0. And the next stage minus we are going to write x as it is. Next I am going to substitute the upper limit, that is x into 1 minus of 0. And the next one is also 1 square by 2 minus of 0. So that is the next step I am prepared. So while simplifying this I get an answer as 2 into 1 I get an 2, and then x into 1 I get an x, and the next step that is minus 2 as it is I go. So the marginal density function of x I am getting an answer as 2 minus x minus 1 by 2. So next we are going to find the marginal density function of y. So the formula for marginal density function of y is f of y is equal to integral of f of x comma y into dx. This will also the same procedure we are going to follow in the previous term. So instead of f of x comma y I am going to substitute the term which is given in the question, that is 2 minus x minus y into dx. Next we are going to multiply in this all these three terms. Then the term becomes integral 0 to 1 2 dx minus of integral 0 to 1 x dx minus integral 0 to 1 y dx. Now we are going to integrate this all terms. So in the next step I am written 2 as it is. We are going to integrate dx alone. While integrating dx I get an answer as x. And the next term while integrating x dx I get an answer as x square by 2. And the next term y dx while integrating I get an answer as yx. Next we are going to substitute this limit in this step. First we are going to substitute the upper limit, that is the 1. So instead of x I am substituting 1, then the term becomes 2 into minus of lower limit. The lower limit is 0, so I am putting 0 in this. Minus of next 1 square by 2 minus of 0. Again minus yx. Here y I get an answer, we are going to substitute for x alone. So while substituting upper limit I get 1, and by substituting lower limit we get minus of 0. By simplifying this I get an answer, that is the 2 minus 1 by 2 minus y into 1 y. So this is the value for the marginal density function of y. So first we found the marginal density of x and y. Next using these two terms I am going to find what is the conditional probability. So first we are going to find the conditional probability of x given y. So the formula for the conditional probability of x given y is f of x given y, which is equal to f of x comma y divided by f of y. Here the f of x comma y, the term which is given in the question. So the f of x comma y value is 2 minus x minus y, and then divided by f of y. Just now we found the value of f of y. So the f of y value is 2 minus 1 by 2 of minus y. So I am going to substitute the two values in this formula. So while substituting and simplifying I get an answer, that is 2 into 2 minus x minus y divided by 3 minus 2y. So this is the answer for the conditional probability of x given y. So next we are going to calculate the conditional probability of y given x. So the formula for conditional probability of y given x is f of y given x is equal to f of x comma y divided by f of x. So this is also the same procedure, that is the f of x comma y y value that is given in the question, that is 2 minus x minus y, and the f of x values, that is nothing but that is marginal density function of x. So the answer is 2 minus x minus 2. So in the previous step we found it that what is the value of f of x, that is 2 minus x minus 1 by 2. So substituting that both values in this equation, so while simplifying this I get an answer that is 2 into 2 minus x minus y divided by 3 minus 2x. So this is the conditional probability of x given y as well as the conditional probability of y given x. So in the whole problem, first we found what is the marginal density function of x, and then we found what is the marginal density function of y. So using these two values, now we are going to find the conditional probability. So for the conditional probability of x given y, I am going to use the f of y, that is we found in the marginal probability function of y, and in the conditional probability of y given x, we use the value that is the f of x, which is the marginal density function of x. By solving all those, we found the answer. Thank you.